Here we have much of what you need to know about quadratic functions. If you know this much and you have the techniques from previous chapters, you can pretty much manipulate any quadratic function. Might be a little more we need to know, but let's just see what we have to say here. Okay, a quadratic function is a function f of x equals ax squared plus bx plus c. And this is the standard form of the quadratic function. Now, we know that if we have an expression ax squared plus bx plus c, we can complete the square on the ax squared plus bx. And when we do, what we get from this form can be expressed in this form. So whether you see the details or not, by completing the square on this expression, we can get an expression of this form, a times quantity x minus h quantity squared plus k. Now that's a handy form because that's the form we need if we want to graph this function by transformations. So this is handy for graphing by transformations. So let's make a little note of that. Didn't leave myself a whole lot of room. But we'll say this is good for graphing by transformations. It's good because right there's your vertical stretch, there's your horizontal shift, there's your vertical shift. You start with the graph of y equals x squared and do that stretch, that shift, and that shift, and you've got the graph of this function. And if this is the expression you get from this by completing the square, you of course also have the graph of this function. Another property of a quadratic function, f of x equals ax squared plus bx plus c equals 0 if and only if x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a, and this is the quadratic formula. Now this isn't the quadratic formula in my way of thinking about things. This entire statement is the quadratic formula. The fact that the function is 0 if and only if x has one of these two values. That statement is the quadratic formula. Some people might argue with me on that, and that's all right. But that's the way I'm going to refer to it, and that's what you need to know about the quadratic formula. The other thing about that we get out of the quadratic formula, and let's consider this argument a little bit. I've summarized it here. What this means is that a graph of f of x whatever this function might be, can pass through the x-axis at only 2 points because the f of x value, of course, is your y value, and the only way a graph can pass through the x-axis is for y to be 0. So if y is 0, that can only happen for these two x values. So we have 2 points. Now we don't know where the points are because we don't know what a, b, and c are, but let's just represent 2 points here and here. And these are going to be known as the zeros of the function, the x values where the function is 0. So here we might have x equals negative b minus the square root of b squared minus 4ac over 2a. And I wrote that kind of small, but I think the resolution's pretty good here. You should be able to read that. The main thing being that I used the minus here. So if b happens to be positive, then minus b minus the square root would be to the left, and minus b plus the square root of b squared minus 4ac all divided by 2a would be to the right. And actually I said that wrong. I said if b is positive, I'm going to say if b over 2a is positive, then this is the point that will be to the left, and this is the point that will be to the right. If b over 2a happened to be negative, then that would be reversed, but we don't need to worry too much about that. Okay, now the point is, if these are the zeros, then of course we don't know if the parabola opens downward or upward, but I'm going to draw it as though it opens upward, and the same argument would apply even if it did open downward, as you'll see in a minute. Okay, so let's say here's our parabola. It's got a vertex down here, the low point. Well, the parabola is symmetric about an axis of symmetry. It's the same on one side of that axis as on the other. That is, whatever you have on one side of the axis is reflected to the other side and matches the graph there as well. So, given that this thing's symmetric, that means a vertical line through the vertex has to go halfway between these two zeros. Otherwise, you wouldn't have the symmetry. So let's see, I kind of missed that, but let's just fudge it a little bit. Okay, here's your axis of symmetry. And here are your zeros. By the symmetry, the zeros have to lie in the same distance at either side of the axis of symmetry. So the axis of symmetry is halfway between the zeros. And what's halfway between negative b minus the square root of all this stuff over 2a and negative b plus the square root of all this stuff over 2a? Well, halfway between negative b minus something and negative b plus something is negative b. So there's an argument that relates the quadratic formula to the fact that negative b over 2a is halfway between these two coordinates, so that x equals negative b over 2a is the axis of symmetry for the graph of f of x. Now, whether you remember that entire argument, whether that makes sense to you, and you should try to make sense of it, but whether or not that makes complete sense to you, this is the fact. The line x equals negative b over 2a is the axis of symmetry. Now, there are other important things you need to know about quadratic functions, but if you know this much, you're off to a very good start.